Hello and welcome to this episode where I'll be explaining the application of binomial theorem. So I have these two expressions on the board. Now look at x plus y raised to power 2. You want to expand it, you will just apply this. You say x plus y and another x plus y multiplying themselves. Then you can start expanding by saying x times x will give you x squared. X times y will give you xy. X times y here will give you xy. Y times y here will give you what? Y squared. And then since we have xy and xy here, we can now have 2xy, x squared and y squared here, right? Okay. This is very easy to come by. Is that not so? How about when this same x plus y is raised to power 8? You discover that there will be a serious challenge. It therefore means that you have to repeat x plus y like 8 times, and you start expanding them and they get complex. So to avoid this, there is something that we use to represent these coefficients. Like here we have 1 as the coefficient of x squared, here we have 2, and here we have 1. And then we'll replace this value that are inside the bracket, and then we can get up to even x plus y raised to power 10. So let's see how it goes. Now there is something we call Pascal triangle. Now in Pascal triangle, values are represented in a pyramidal shape, right? So we have 1 and 1 here and 1 here. Then we can now have 1 plus 1 will give you 2, and then 1 again. Then we have 1 again, 1 plus 1 plus 2 will give you 3, 2 plus 1 will give you 3, and then we have 1 again. Then we have 1 here again and 1 here again. So 1 plus 3 will give you 4, 3 plus 3 will give you 6, 3 plus 1 will give you 4. Then you can also have another again, 1 plus 4 will give you 5, 4 plus 6 will give you 10, 6 plus 1 will give you 10, 5 plus 1 will give you 5, and then you have 1 here. So this triangle can go on and on and on and on even to the 10th position. So these coefficients are for, let's say, x plus y raised to power 0. You have this. Then for x plus y raised to power 1, you have these coefficients, right? And then for x plus y raised to power 2, you have this coefficient. So let's confirm it and see. The coefficient that we'll have here, look at it here, 1, 2, and 1. See it, 1, 2, and 1. Then this is for x plus y raised to power 3, x plus y raised to power 4, x plus y raised to power 5. So if we want to do x plus y raised to power 6, then it will be 1 plus 5 will give us 6, 5 plus 10 will give you 15, 10 plus 10 will give you 20, 10 plus 5 will give you 15, and then 5 plus 1 will give you 6, and then we have 1. So this will be the coefficients of expanding x plus y raised to power what? 6. It goes like that over and over again. So this will be for the Pascal triangle explanation. And then if you want to use it to solve any problem, you can use it to solve any problem. So I'll meet you in the next video where I will apply this to solve a problem. But for now, let's just take one example. Let's say we have x plus y raised to power 3. So in this expansion, we know that our coefficients will be 1, 3, 3, and 1, right? So I'll have 1 plus 3 plus 3 plus 1. So I'll start putting these values: x, y, x, y, x, y, x, y, since all of them are addition, right? Okay, so the increment will start from x. So x here will be 3. It will decrease to the right. So this will become 2, this will become 1, and this will become 0. Then y will start from here, since it is in the left hand side, and decrease from right to left. So we have 4, 3, we have 5, 4, 3, 2, sorry please, this is supposed to be 3, 3, 2, 1, and 0. Okay, so continuing, we know that 1 times x raised to the power 3 is x raised to the power 3, but y raised to the power 0 is 1, so it's gone. Plus 3x squared, and y raised to the power 1 is still existing. Then plus 3x, and this y raised to the power 2 exists, plus this 1, this x is raised to the power 0, so it will go 1 times y cube will still remain y cube. So this will be the expansion. So if you look at the coefficient, it still remains as this, right? Okay, let's give us another example. Let's use x minus y raised to the power 4. Now let's write the coefficients from here. From here, we have 1 plus 4 plus 6 plus 4 and plus 1. Now for this place, we're going to be writing x and then minus y, because the y is negative, right? So we have here to x and then minus y. Here too we have x and then minus y. Here we have x and then minus y. And here too we have x and then minus y. So this is raised to power 4. So the first value, which is x, will have the power of 4 here. It will go back to 3 here, 2 here, 1 here, and 0 here. Then 5, which is on the y, which is on the left hand side, we have 4, 3, 2, 1, and 0. So continuing from here now, 1 times x raised to the power 4 will remain. This will go, right? Anything raised to the power 0 will become 1. Then plus 4 x raised to the power 3 and y raised to the power 1 will remain. Plus 6 x squared into y raised to the power 2, right? And minus here. Then plus 4x into minus y raised to the power 3, right? Then plus x raised to the power 0 will be gone, and then you are left with what? Minus y raised to the power what? 4. Now we should recall that a negative number raised to an even power will still remain positive. So like 1 minus 1 raised to the power 2 will still be 1, right? So minus y raised to the power 2 will still be what? Y raised to the power 2. Okay, so let's solve the problem here. So here now will be x raised to the power 4. Okay, so let's recognize this minus sign now. Plus times minus will give you minus, right? So we have 4s cubed, and then the y remains. Now let's do same here. Here, since y is raised to the power of an even number, it becomes positive, so it will be plus 6x squared y squared. But here y is raised to the power of odd number, so the answer will still remain negative. That means this negative will multiply this plus, so we have minus 4x y cubed. But the last one here, this y is raised to power of even number, so this minus will cancel and becomes plus, so plus y raised to power 4. This will be our final answer. Alright, I'll stop here and then we'll solve other advanced problems in the next video. See you for now and ciao ciao.